Problem number 7. So you're given these 3 points where A is some unknown number here, P, Q, and R. And you're given a plane here in part A, 3x plus 16y minus 30z is equal to 68. So in part A, you're asked to find the value of A, so the plane containing these 3 points. So in general, 3 points determine the plane is parallel to the plane 3x plus 16y minus 30z is equal to 68. So the one piece of information that we need from this plane here is that this plane has normal vector. That marker isn't working too well right now. This plane has normal vector. That's working better. 3, 16, negative 30. We just read off the coefficients there for the normal vector. So we know that this has to be the normal vector, not just for this plane, but also for this plane as well. So if we, here is P, Q, R. So the idea here is this is our normal vector. It's perpendicular to all the vectors that lie parallel to this plane. Okay, how does this give us information? How does this give us information about figuring out what A is? Well, what we can do is the following. What is a vector from P to R? Okay, vector from P to R, equation for this, this vector from P to R, so it's going to be components of P minus components components of R minus components of P. So, that should be -1 plus A, comma, -1 minus 4 is -5, -3 minus 4 is -7 here. So this is PR. I could also write down PQ if we want to, but here's the thing. What do we know about the vector PR and the vector 3, 16, -30? These must be orthogonal to each other. So we must have n dot PR. Well, I'm advertising a radio station all of a sudden here. Needs to equal 0. So what is the dot product of n with PR? It's going to be 3 times -1 plus A plus 16 times -5 plus -30 times -7, and this needs to equal 0. So this is -3 plus 3A minus 80 plus 210 needs to equal 0. And if you crunch here, you get A is equal to -127 over 3. So not a particularly nice number, but we can do this. So what is so A is -127 over 3 here. That's the value A, so that the plane containing PQR is parallel to this plane. If you're suspicious of this, what you can do to check, I'll let you check this, is that also find the vector PQ. Find the vector PQ using, now P, the first component here is 127 over 3 here. Using this P and this Q, find the vector PQ. If you take the dot product of this with n, you'll also get 0. And then part B says, use the value A that we just found to write an equation of the plane containing the points P, Q, and R. We actually didn't need that. We don't need the value of A here, because we have the normal vector. So 3 and 16 and -30. So what do we do? 3 times x minus something, plus 16 times y minus something, minus 30 times z minus something. and we will plug in x is, we can plug in any of these 3 points here that we want to. I'll just do r here. X minus minus 1 is x plus 1. Y minus minus 1 is y plus 1. Z minus minus 3 is z plus 3. So this down here is our final answer. You could use any one of these 3 points here, but this is a final answer.